Hey, what's up? I'm Jason, and today we're going to talk about saving memory in your Unity game. We'll talk about what happens when you reference and load assets currently, and then we'll talk about the asset bundle system and, more importantly, the new addressable system that's built on top of it. In fact, that's going to be the main focus of this video. We'll talk about some of the cool benefits that you get from it, like faster build times and smaller downloads, of course, along with faster iteration, which is probably my favorite, which just means hitting the play button and having it start as fast as possible. But you also get a benefit of faster load times and just scene loading and scene transitions. So if you're interested in this kind of thing, the best thing that you can do and the thing that will make me happiest is just share it somewhere. I don't care where, anywhere that you share it that YouTube knows about really helps more than anything. If you're not that interested, then like and subscribe and all those things too. And if you have questions about this stuff, please drop a comment. Also, if you go through the video and you have other suggestions or recommendations for more stuff that I didn't talk about in here, please just drop comments down below and let me know, and maybe I'll do some more updates and stuff. All right. So I've got a scene set up here where I pulled in the free cartoon effects. Still love that pack. It's just an awesome little particle system that's free to use. And I've got a particle spawner object here that I can click on, and you'll see it's got references to 4 things, these particle references. And they might look a little bit weird right now because they have drop downs. Don't worry though, we're going to dive into that in just a moment. So let's hit play. There we go. And let's watch what happens when I click my 3 little buttons, or 4 little buttons. I said 3, 0 through 3. It's 4 buttons, right? So we click on them and we get some particles appearing. That one actually spawns a whole bunch of particles. That one spawns 1, that one spawns 1, and that one spawns 1. Nothing special, right? Who cares? We're spawning particles. But let's look at the profiler. So if you haven't opened the profiler before, it's just under Window, and then Analysis and Profiler. And here I've got my profiler scaled down and just showing the memory part. But if I pull this up, you see it's just the normal profiler, same thing that you have. Just scroll to the memory part, and then I drug it down like this so I can see it a little bit easier. So what we want to look at here in the profiler though isn't this little chart. I really don't care too much about that just because I can't see the numbers on there, and right down here I can read them perfectly. And I want to look at this texture memory. Look, it says that we have 116.5 megabytes of texture memory in there. Now if I click on 0, watch what happens. See, it went up to 17.7, and then look at that, it went right back down to 16.5. Or 116.5. And if I click on all of these, watch, I kind of click on them all at the same time, you can watch those numbers go up and then drop back down. Now you might think like, oh, okay, whatever, it dropped back down a couple megabytes, who cares? It's because the thing got destroyed. It's actually not because the thing got destroyed at all. Because if we do this in another scenario, in fact, let's go do it now. Let's go open it up without the addressables and see what happens. So we'll go into our scenes, go to our basic one, and hit play. This is a very similar example. I'm going to select the spawner though, and let's take a look at it. This might look a little bit more familiar, these elements with the little search box, right? That's how we normally reference things, or how I at least used to normally reference things before I switched to using addressables for as much as possible. So here we go. We've got our spawner set up, and I'm going to go to the profiler one more time. And it's important that I do this right at the beginning because you'll see why. Look, we're at 116.5. Let's hit 0. Oh, we're at 118. And did you notice that it didn't go back down when that got destroyed? And it didn't go back down. Didn't go back down. I'm clicking on all of them. I mean, the memory usage, of course, goes back down, but the texture part isn't going back down. So we are destroying the objects. We're still freeing up some of the memory, but we're not unloading those references to those textures that we're no longer using. Now, we might not want to necessarily unload them all either. It's possible that we have a scenario where we don't want to unload them ever, and there's a way to do that. We'll talk a bit about that. But in my case, I've got some games where we've got a lot of assets. We've got a lot of memory pressure, and if we're done with something, we're not using it anymore, we want to unload it. We want to pull that out of memory. Now, if it's something that we're just going to respawn and keep popping up over and over, of course, we'll just pull it. We won't unload it. We won't need exactly this thing to fix it, right? We'll fix it a different way. But for the cases where we're not doing that, where we actually want to free up the memory, we're not going to use it again until we need it again, this is a perfect solution. Now watch this. I'm going to stop playing. We're going to play one more time. And look at the memory. Because this is the best part. Still at 121. Watch. I click these. and no change. Now, if you're new to Unity, this probably comes as a bit of a surprise. What's actually happening is all of these things were actually loaded in beforehand, or they're loaded in with the build when the scene loads. It's just the editor's kind of not really pulling them in until I hit the button the first time. But if I did a build, they're going to be in there the first time always, just because they're referenced. In fact, I like this. Today I learned prefab references in Inspector are loaded into memory, even if not instantiated. There are a lot of posts like this. A lot of time people discover this. It's like a new revelation that, oh, I didn't realize just because I'm referencing these things, Unity assumes that I'm going to need them. It loads them in and it has them ready to use. Now, if you use asset bundles before, you probably know this stuff and you're like, okay, this is dumb. I know, obviously we have to manage our bundles. We have to manage our assets or else we're going to have all these things in memory. If you're used to asset bundles, then hey, this is going to be good for you too, because we're going to dive into, well, this is kind of the replacement for asset bundles. It's actually a system built on top of it, and that's the addressable system. And I think it's time for us to dive into how to actually do it. So let's do that. All right, to demonstrate this, we're kicking off a brand new project. I want to make sure that I don't skip over anything and that you don't miss anything. So I've got my project view here, and I'm just going to go find that cartoon effects pack again. So just go to the project view, type in cartoon effects. And on the asset store tab here, I can see it. It's right there. I just right click, hit show in asset store, and import the entire thing. There we go, and I've opened up the demo scene just to make sure that everything looks cool and fancy like it always does. So we've got our cartoon effects in. The next thing we need to do is, well, I want to go back to my sample scene, and then I'm going to open up our package manager. So we go to Window and Package Manager, and we want to find the addressables package. So just type in ADD, and it should find it, and then we'll install it. Once that package is done, we should be able to go to Window, and then go down to Asset Management, and we should see an addressables option. Click on that, and you'll get a new window that lets us create addressable settings or import them. We're just going to create new settings. So click on that button. And we get the new addressables window. And we also have a settings object. If I click on this profile and hit inspect profile settings, you'll see it actually selects it down there in the project view. This asset is my settings for the addressables. And then I have an inspector over here where I can actually modify the settings for the addressables. We're not going to dive into that just yet. Instead, what we're going to do is go find the objects that we want to make addressable. The objects that we want to be able to spawn and despawn and load and unload from memory. So to do that, I'll just go into my normal project view, and I'm going to take my addressables window and I'll just dock it right up here for now. And I'll get rid of the package manager because we're not going to need that for a while. In fact, I don't think we're going to need that at all. So let's go into cartoon effects and just find a cool particle effect. So here's smoke plus text. And look over in the inspector. You see here where we have the name and then we have the tag and the layer section. Look underneath, there's that addressable. See that right there? Click on that, and then we suddenly get a text field where we can set a path for it. And if I expand out this default local group, you'll see that the address has appeared here. So the address is here, or the address to the actual object. The path is showing right here. Very long too. And there's a little button that I can click on and a label thing. First, I'm going to shorten this path down because it's really just too long. I don't need this entire path or this entire thing as my address. So, whoops, let me go reselect that. I accidentally hit the wrong hotkey. So I can reselect it just by double clicking on that little icon, by the way. And then I'll go over here. Let's find the end of this. Just use Control and the arrow to kind of bounce around. And I'm going to grab just the end part, hit home, Shift and home, and then hit delete. And I'm going to call this like VFX/CFX explosion. So that way it's somewhat grouped, but it's not this giant long path. And I don't know that this is necessarily a great way to name them. I just don't like having the very long paths, and I don't want them to be too short. So I've been putting the type of thing they are, and then a slash and what the name is, or what the address is. So notice that updated in here too. But the path part still goes to the prefab. And I think I said those backwards earlier when I was saying it. The address is on the left, the path is here. Hopefully if you were watching, you're like, what are you talking about, Jason? It says the opposite right there. So there we go. We've got an address, we've got a path here, and that's set. We don't have to do much else except for click on this build and hit build player content. So we now have an addressable explosion that we can use. We just have absolutely zero code to use it. So let's pull in some code. I don't want to just sit here and type it and waste your time. So I'm going to pull it all in. We're going to go really quick over what the code is and how it works. All right, let's start our dive into code with something simple. You may have noticed an extra file here that I deleted, by the way. That was just extra crap that we didn't need, so it's gone. Let's open up the particle spawner button first, though, because that script is relatively simple. We'll open this up, and here we are in Rider. I'm going to scroll that over, or slide that over just a little bit. We've got a couple fields here. We have an index and a spawn count. This is just so I can control how many we spawn. The index is for which particle system we want to spawn. Right now I'm trying to keep it simple and just do them by order in that element array that you saw. And we'll dive into that in just a moment. You'll see how it all works. But we've got one method here that's public, this request spawn particle. Might have kind of a weird name too. I'm wondering why it has request, and we'll be diving into that too. But what we do here on line 11 is loop through our spawn count. We find the particle spawner and we call spawn and we pass in our index. Now, of course, super inefficient. Don't do this for real. Don't loop through something and do a find object in the loop. But this is a very simple example, and this is not the important code. This is the 0% important stuff. I just wanted to show it so that you know what it is and kind of understand how it works if you're trying to replicate this. So we've also got an onValidate method. OnValidate just gets our index, and it does that by getting the transform sibling index. So when I put a bunch of buttons under a panel, it goes, hey, button 0 is, or the first button is button 0, index 0, and then it sets the text to say 0, 1, 2, 3, 4, or whatever. And then in the update method, we check to see if a key was pressed, and if one of those was pressed, we call that request particle or spawn particle. Now, the other reason that this is public is because it's on a button, and I just link it up in the scene. Now, I'm going to do that real quick and show you how that's done, but we'll do it really fast so that we can dive into particle spawner stuff. So we just go in here, we go game object, create a UI, and we'll make a button. We'll go to the scene view, we'll find that button, go to 2D mode, zoom out real quick. On this canvas, I'll just add a grid component. So let's add a grid layout group so that it puts them all in order, and we'll make them like 30 high, 100 wide. That looks good. Select the button, and we go down here and we'll add our component. Just search for the word button, get our particle spawner button, and you can see that the text already changed to say 0 on it. And if I duplicate that button, it would say 1 on the next one, but I don't want to duplicate it yet because I want to add the on click. So click on plus for the on click, take the particle spawner, drop it into there, select no function, go down here, pick particle spawner button, and then request, oh, it's just barely on there. You can see the REQUES right there in the corner, but we want to pick the request spawn particle. So I've got that there. Now I want to just duplicate this button a couple times. 1, 2, 3, there we go. I've got 4 buttons, and look at that. This time I'm going horizontal. I could change it and go vertical or something, but let's just go across the horizon, make it a little bit different this time. There we go. We've got our buttons set up, and I'm going to save my scene. Now let's talk about the actual code that we're here for, the addressable stuff, the particle spawner system. And let's do that by just opening the script up. First, well, let's look at our using statements. We've got a using statement for addressable assets and for resource management.async operations. It's important to note that if you are using the assembly definitions, sorry, I lost my word there, but if you're using assembly definitions, you'll need to make sure that you reference these things in your assembly definitions too. Here we're not doing that because we're just trying to keep it simple, but it's something that you might come across if you're using those. Now we have in here a particle references that is serialized, and it's a private list of asset references. And this is very, very different from normal. Usually you wouldn't see a list in a serialized thing, and asset reference is not a type that anybody's used to. It's also not some special type that I made or anything. It's part of the asset bundle system. Asset reference is what we use to reference our objects. So let's go put the particle spawner script on a game object and see what that looks like real quick. So go over here, we'll create an empty game object, and I'll just call this particle spawner with some square brackets. Just makes it a little easier for me to find it, and we'll add the particle spawner. Now, if I expand out the particle references, you see that it just has a size of 0 and nothing else. And if I change the size to 1, it works a lot like a regular array would. So it's just like you would expect, but now we're using a list. And it has a slightly different drop down. So normally when we do a game object reference, we have that little circle. And here, remember I told you we'd get this little drop down thing that kind of seems different. You might be wondering what it is. If we click on it though, you can see that we can actually find all of our addressables here. I only have one thing here, so I can just select it. But if I have a big list of things, I can just type in there and search and filter. When we add more things, we'll do that. We'll filter it so you can see that in action, or you can just go ahead and add a couple more things yourself if you want. So there we go. We've got our particle spawner set up, and we've assigned one particle, or particle reference, I guess is what I've named the thing. Let's dive back into the script now and see how it works. So our spawn method here is the one that's getting called. And don't worry about these two dictionaries of queues. We're going to talk about those in just a moment. One of them is for more complex stuff. Actually, they're really both for unloading things. We'll talk about them in a bit though. But let's look at the spawn. So we have our public void spawn, and remember this is called from our particle spawner button. I'm in writer, so I can click the one usage and actually go right back to that bit of code. I'll hit F12 to go back to the spawn. So we pass in the index based on the button, so 0 for the first one, and all the way through. We check here to see if the index is invalid, just to make sure that it's not bad, or that we're not putting in an index that's higher than our particle reference count, or higher than or equal to, because we don't want to have since we're 0 based, we don't want to have a number greater than our count. Then we get the asset reference from that list by index. Nice and simple. The next thing we do is check to see if the runtime key is valid. If it's not valid, I just log it and return. I'm not 100% sure that we need to do that, but I think that we do, because if the reference is just set to nothing or empty, then we're going to run into a problem. Now, I might not need to do the log, but I should probably definitely at least return out of there. The next thing we do is check to see if this async operations handles contains key of asset reference. And you're like, what is this? And this is because my asset bundle system, or the setup that I have, is a little bit more complicated to be able to automatically unload all of this stuff for me. So what we're doing here is, let's go take a look at the dictionary. We have a dictionary that has a key of asset reference. So we'll have one entry in this dictionary for every different reference that we use. And then we have an async operation handle with type GameObject. So what this is doing, well, let's go back down to the code. We're checking to see if it exists. If it does exist, then we are saying, hey, if this thing is done loading, then spawn from our loaded reference. If it exists here, but it's not done loading, then we enqueue it. So all of this is kind of like our after we've already loaded and spawned and we want to spawn more things code. We'll talk about it in a moment, but this isn't really how it works or the order that the things flow in. So I'm going to minimize this. And what actually happens the first time we come through is load and spawn will get called, because we're not going to contain that key yet. So let's dive into load and spawn. Load and spawn calls addresables.loadAssetAsync, and here's where we give it that asset reference. So this is how we load the asset without just instantiating it. And here we're literally not instantiating it. We're loading it into memory and getting that asset operation, or that async operation handle, and then we can use the asset reference to start spawning our object. And let's take a look at how that works. So we get the operation here. Remember, this returns that async operation handle, and then we add it to the dictionary with that asset reference as the key. And then we add a callback on the onCompleted, or the completed event for our operation, or our loading asset async. And when this is completed, this is the code that'll call. We'll spawn a particle from our loaded reference. And then if we have any queued up spawn requests, we'll spawn those as well. Now, again, I feel like this is kind of complicated, but hopefully you're able to follow along. And again, I'll make the code available so you can just step through it if you need to. So let's look at the next part. So what happens? We call spawn, we load the asset, or we tell it to load, but since it's asynchronous, it's not going to finish right away. We're going to kick it off, we're going to put it into this dictionary, and then we're going to say, hey, whenever you complete, run this little chunk of code in this little lambda statement. And the first part that's going to run is the spawn particle from loaded reference. Let's go to that, because that's going to look a lot easier. Here we say asset reference. which is our new asset reference that we now know is loaded. Instantiate async, and we give it a position and a rotation, just like we always do. Here I'm giving it identity because I don't care about the rotation because it's a particle, and we're just giving it the position that we passed in from our other method. In fact, let's go back up one. Oh, it's right here from get random position. So get random position, just giving us a random spot, and that's what's getting passed into here. So we call instantiate async, and again, notice that we're calling something on the completed. So we're registering for that completed event, and the code that calls when this thing is done instantiating is right here. And this is a little bit different. This is kind of where using addressables gets to be a little bit different than spawning regular game objects, because we're still instantiating it in an asynchronous pattern. We need to use this callback to do things when it's done. There's kind of a way that you can hack it in and make it synchronous. I wouldn't recommend it, and I don't think that Unity recommends it. They have all those methods marked as obsolete, and I think that they generally recommend going with the asynchronous ways, and so do I. So what happens here is we spawn the object, the completed fires off, and it runs this chunk of code, like I said. But here we're checking a couple things. First, we're seeing that if this spawned particle systems dictionary contains the asset reference. This spawned particle systems is a dictionary that's a list of game objects. In fact, let's go look at it. It's a dictionary of lists of game objects. So we have an asset reference, and then this list would be all of the spawned versions of that particle system that we have out in the world. So it's by the key of the reference, and then the instance is that list, or the instances are in that list, I mean. So after we've instantiated that list, if it wasn't already instantiated, we add the result here, which is the actual game object, to our list. So that we're saying, hey, this is just a list of all the spawned particle systems that we have. And the reason that I'm doing that is so that when we run out of spawned particle systems, we can unload this thing automatically, and I don't have to go in there and manage it some other way. This is basically just my little easy way of managing this thing. Now, I think in a real world scenario, of course, you're going to want to be able to flag certain things as don't do this, or perhaps put some timer on it so that if it's unloaded and none of them have been used for 30 seconds, or maybe not in this scene or whatever, then remove them. But for now, I think just clearing it all out right away is a great example and shows how easily we can do that. So we've got our spawned particle system added to the list, and then we add this notify on destroy component. You're probably like, what's this? What is it? I don't know. Well, we'll dive into that in just a moment. It was one of our 3 scripts. That's our last one. In fact, let's dive into it now because it's tiny. It's a little mono behavior that has a destroyed event on it. It has an asset reference and an on destroy. So when this thing is getting destroyed, when our particle system is dying, we just call destroyed.invoke and pass in the asset reference that we have. So what is that doing? It's just telling us, well, here, if we look at the destroyed callback, it's calling into this remove, which is releasing the instance. So this is, again, I guess a very important part of how this all works, but I don't know if it's very obvious or very clear. When we spawn these objects with the addressable instantiate, we need to release them with the addressable system as well. So we can't just spawn it, have it destroy itself, and have it go away. We actually need to release it with this addressables release instance. Now this notify on destroy is not obviously the simplest way to do it. It's just that I'm using particles that have a on destroy timer already built into them with the cartoon effect. So they already kill themselves after a certain amount of time. I didn't want to add pooling and didn't want to overcomplicate this. So just on destroy, we're calling in and getting that call back to here. So that's really all this is for. Don't think that you necessarily have to do it that way. You just need to find some way that when your object goes away, when you destroy it, you call the release instance on it. So we're calling release instance. And then we go into our spawned particle systems list for that asset reference and just remove the object. Again, remember that on destroy gets called before the game object's null. So we still have a reference to the game object even though the destroy was gone. In fact, that's why I remember when you do the not equals null check or the question mark dot operator, it'll tell you, hey, this could be invalid. And if you hit the little button in writer, it'll tell you exactly why. And it's because the object's not completely gone. So we still have the object long enough in that onDestroy callback to be able to remove it from the list and release it. And then here, this is kind of where I do the rest of the little bit of magic. We check to see if that list is empty. If it is, I just write out a little log saying, hey, we emptied out that list, which is, of course, just generating some extra garbage for no reason, but just showing us what's happened. And then if the asset reference is still valid, we release it. So we call not the release instance, but the addresables.release, and we release the operation handle. So this is why we're holding on to that handle. We need to release that handle to remove the object from memory completely. Whole lot there. So let's dive into the project one more time and just see it in action, but this time with the addressable memory profiler or the addressables profiler. So go to Window and then Asset Management and open the addressables profiler. And then if I hit play and I click on some of my buttons here, let's see, you see that nothing really shows up, but if I hit clear and click on them, you see that we start to get a little bit of data, but I'm not getting any data about this explosion. I'm going to stop playing, and we need to go to the addressables window one more time. Go to the profile settings, or just go select this object and go to them. And we need to check the Send Profiler Events button. Now if I go back in and hit play, and again, I may need to hit the clear button again. I think it's just a beta issue. But if I hit, let's hit clear. I hit play, you should see that my game object is actually showing up there. And if I click fast enough, you can see that I'm getting a whole bunch of memory usage from it, and then it drops back down. And it's not a whole bunch, it's just because it's small texture. But if this were a big thing, you could see I'm spawning all these instances of it at least, and my memory usage is going up. And then when they're all gone, as soon as the last one's destroyed, this thing disappears. Perfect, right? So that's the goal that we're kind of aiming for. We want to be able to have these things load and unload. Maybe not always automatically like this, but at least in a way that makes sense for our game. And it's pretty easy to do. And once you're on this addressable system, not only can you do all of this, but you're going to get much faster startup times because all this stuff doesn't need to be loaded into memory right away at the beginning of your game. You get just better memory management in general. And I think you'll be kind of set and ready for the new way for setting up systems and games in the future. I think that the new ECS stuff, or the new dots that it's coming out and becoming a big thing, is going to take addressables kind of probably to the next level, or at least use addressables a whole lot to make the systems work. And I think that if you're building any system, any game that just has to get updates or has to get patches, or you just want to have a nice, easy to use system, this is kind of it. So if you're not using addressables yet, I highly recommend you just experiment with it. Grab this sample project, play around with it a little bit, see what you can figure out, and then see if you can find a good way to integrate it into your projects, because it does have a big payoff. I think it's really useful, and it's something everybody should probably figure out eventually. Anyway, if you like this kind of thing, again, the best thing you can do is by far just share it. Share it everywhere you can. Also, I wanted to say a special thanks to everybody on Patreon. I say it all the time, but you guys really are awesome, and it's really cool that everybody really supports the channel and all the stuff we're doing. And yeah, if you're not into either of those things, a like and a comment is great too. Anyway, thanks again. Appreciate it. If you have tips on addressables, please share them. I'd love to hear more. And if you want to see more addressables related content, let me know, and I'll keep shooting more of these videos.